Hello. Testing sound. Yes. Woo hoo hoo. Hello. We're back. Oh, what is with the color? Hello? Hello. Now I'm more orange. Now I'm whiter. I don't know what's going on. I don't know what's going on with the white balance in the camera. Good morning, everyone. Good afternoon, good evening, whatever this live stream may find you. Welcome back. We have a few people in the chat. How's everyone doing? I am very happy to be here. And am I ready to do this? I think so. I think I'm good battery wise. Yes. So, hey, Hex, how are you doing, sir? Oh, can I share something with the community? I was on vacation last month and I was very happy to receive a message from Hector Ceballos, who's on the chat right now. And he was like, oh, are you going to be in town? You want to meet up for a coffee, whatever? And then we met. We never took a selfie, man. That's a fortunate. Oh, we could have taken a nice Anyway, I was very happy, very pleased, and very humbled to meet people, wonderful people from the community like Hector. I had a beautiful coffee with him, and I want to say that like meeting people in from the community in the physical world in person doing social stuff is actually wonderful. I miss it a lot. Hopefully very soon we will transition into being able to do that more often. I'm also very excited because the semester, so I'm starting to teach again in the fall in starting in September, and I'm going to be meeting finally a lot of the students that I've been teaching for the past year fully virtually. And actually, I'm meeting a student that just got here to Cambridge in a few hours. We're gonna grab a coffee, so I'm very excited about the prospect of coming back to a little bit of normality. Anyway, I just want to say that whenever I'm somewhere traveling, I'm more than happy to meet up with people, just like Hector reached out to tell me, let's just grab a coffee. I'm super happy to do those things anytime. Dusko, how are you doing? Victor, yes, it was a long break. It was a 1 month, it was like a 4 or 5 week break, right? I needed a break. It's been a tough year, and I've been also working in the background actually during that break. I took yeah, it was very nice. But I am back here in Cambridge, Massachusetts, the United States, and I'm ready to roll again. I think it's going to be a nice year. I mean year. I go by the academic year typically. So Chandra, how are you doing, sir? Nice to see you. All right, so what are we doing today? First of all, it's been a while, so let me do the official thing. Welcome! My name is Jose Luis. In case you're new to the channel, this channel is called Parametric Camp. We do computational design live streams, and while we're doing these live streams, we record tutorials that then we edit, we chop, we blip, 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 we clean up, and then we publish as permanent knowledge that you can access if you want to learn anything related to the world of using algorithms and using computational logic to be more creative, aka computational design in a nutshell. Um, Andres, how are you doing, sir? Salvador, good morning. All these beautiful faces again. Nice to see everyone here. Um, so, this is who we are. Now, if you are new to the channel, you can just watch these videos. You're more than welcome to subscribe, hit notifications, like this video, etc. We have a Discord server that we use for offline conversations throughout the week in between live streams. So you're more than welcome to participate in the chat right now, or if you want to participate in the offline part, I just posted a link on the chat that you can access to subscribe to the Discord server. We have a bonfire, we have general conversations and s'mores. We have work sharing channels. We have a lot of channels for Python, C#, blah, 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 whatever, where people share questions and help each other. It's very nice. I'm very happy about the work that many of the people in the community are doing to help each other. And if you want to stay up to date about when we go live, the best thing you can do is follow us in some kind of social media. I am a bit more active on Instagram these days, but we also do Twitter, YouTube. You can turn on notifications and to get a message. And otherwise, we have a Google Calendar that you can subscribe to, and you will get notifications of when are we going live. And I believe actually, for example, Andres, who's in the chat right now, he is subscribed because he just texted me, "Oh, I'm very happy to see you back again." Anyway, so all right. So, and what are we doing today? So I have a few announcements and news. So we are in August, and I plan on recording and going back to normal schedule of recording live streams during the month of August. And during the month of September, I will start school again. For those of you who may not know me, I teach at the Harvard University Graduate School of Design. I teach in the fall. I teach a big lecture course called Introduction to Computational Design. And the lectures are actually open source on YouTube. So if you Google a little bit, you will be able to find them. And I also teach structures in the fall, and then I teach a research seminar in the spring called Enactive Design, which is more about the exploration of human-machine interaction for creative purposes. So I'm going to be teaching. I teach a lot in the fall. I have a lot of teaching, and the schedule just came back to me, and I believe I have Fridays busy with teaching. So I need to figure out what are we going to do about the live streams. I would not want to do them on Saturday for many reasons. It overlaps with the coding train. I'm also trying to have some personal life. So I'm looking at Wednesdays right now, which is the potential good candidate. So we may, start in September, switch to Wednesdays. Maybe. I'm thinking about it. What do you folks think? Would you like that? Would you like other? Because otherwise it has to be Friday afternoon only. And I would like to have the full day in case we do double streams. I don't know. So let me know. Let me know in the chat if you have preferences about when would you like to see the streams. I think the options would be Wednesdays or Tuesdays, I think. The options would be Friday afternoon, my time only, or Saturdays. Just let me know on the chat, what do you prefer? That will be starting September. Now, I have also a few news. So wait, let me find, where is this? Let me find something here. Where are we? Okay. Yes. So if you go to playlist on the channel, and if you go to Introduction to Parametric Modeling, I am very happy to announce that as of today, the playlist is done. We have published all the work and all the videos that we recorded in May or in June, I think. They're all public, they're all available now. So anyone who wants to follow the playlist has the full content right now. So that's great. And that means that we have a full course on Introduction to Parametric Modeling. So that's great. I'm very happy about the work that we did here. And if you remember, some of the work that we did to make this happen involved me sitting down for, I think I wanted to do it. So we ended up doing live streams intensely every day, 2 live streams back to back, two, for what I thought it was going to be 1 week, but then it extended to 2 weeks. And we needed that to finish the full playlist. So, but I did like the model because sometimes if I do things so separate from each other, I lose track of things. So the announcement today is that for the fall, so there's another playlist that I really, really want to get done as soon as possible, which is going to be called something like C# development for Grasshopper. And in that playlist, or in that course, What I want to go over is how to use the C# script component inside of Grasshopper to create your own prototypes. I want to go over Rhino Common and how to use Rhino Common. I want to go over how to write your own plugins and compile them and put them on Rhino for Food, etc., etc. Food for Rhino, whatever. So basically, I want to combine what we learned on into the parametric modeling with also what we learned on learning C#, this other playlist. So I want to combine them both so that you now have all the skills to write C# code and to do C# development inside of Grasshopper, which I think is very nice. And I also kind of need a lot of this content for the courses that I think and the classes that I teach at Harvard. So I'm actually thinking that I may do another one of those intensive marathon weeks sometime very soon, maybe even next week, if not in 2 weeks, maybe even starting next week. So I'm probably gonna do a week or a week and a half of back-to-back 2 live streams per day, going over all these topics, scripts in C#, plugin development, and all those ideas, so that we can have that list ready by September 1st. So I need to sit down and plan this, and I also need to sit down and make a script of the content that I want to go through. Would it be interesting to have a live stream where we design that script, where we design the curriculum of that playlist together? Is this something that you would like to see? Maybe it's also something that it could be interesting because you can contribute to. So actually, that's not a terrible idea. Salvador, 100 for what? for the playlist or for designing the curriculum together? What do you think? Anyway, so that's going to happen very soon. Also, can I give Salvador a big shout out? Hold on, let me show something. So Salvador Concalwa, whom you are seeing on the chat right now, he is maintaining this repository called Computational Design C# to Python, which, not that I like Python, but what he's doing is he is translating a lot of the work that we're doing in the live streams and in the algorithmic modeling challenges and in the geometry jams and all of that, which here in the channel we mostly do based on C#, and he is translating it to Python within Grasshopper. So I think it's a really, really interesting work, and I think it's really valuable. So I want to give Salvador like a huge shout out and many thanks. I'm going to paste the link here on the chat if you want to check this repository in case you're a more Python inclined person, which, I mean, I don't know why would you do that, but I respect everyone's computer programming choices, I guess. All right. Alrighty. So, what else do we have for today? Yeah, and what are we doing today? So I have good news and bad news. Where do you want to start? Sounds great. Both. All right. Okay. So we can let's do that. Yeah. All right. So let's yes, we have good news and bad news. What are we doing today? So today it's been a while since I was live streaming, so I wanted to take it a little easy. So we're not gonna do crazy exercises, and I also want to spend some time thinking about the curriculum of the playlist that I want to do new, which I've kind of decided that we're going to design it together. So we will do that at some point. The first day we start thinking about that. Anyway, before, what are we doing today? So today, last time we met, remember that I was not very happy with, remember that I was not very happy with the video that I recorded as an introduction to the playlist. So the welcome, this is introduction to blah, 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 whatever. So we recorded it again. After we did that, I was reviewing the video and it turns out that I was still not happy with it. So bad news is that I'm going to spend a little time today recording that video again, which was extremely boring, I understand. But the good news though is that I'm going to follow the advice that I was given last time, which is why don't you write down what you want to say and then you just say it. It's going to be easier. So, given how annoying I am being and perfection, and OCD I am being about this, I think I'm going to follow that advice. So, I have written myself what I want to say in the video. So, hopefully, this time it's just going to be a couple rounds of like saying what I want to say and then be able to edit the video as I want to. Hamidresa, Pythonophobic. I like that a lot. Pythonophobic. Well, I mean, am I to blame? Who's not afraid of giant snakes? Seriously, right? Who chooses a giant snake to name a programming language? That makes just no sense whatsoever, right? Anyway, I don't want to get cranky. So I'm going to record this thing. I'm going to record this video, which probably will take us not a lot. And then I want to take it easy and I want to do a couple of geometry gems. So we have a lot of stuff. So I may want to do a couple of like really simple geometry gems, like I don't know, like unitizing a vector, like angle between two vectors, a plane from 3 points. I have a list of things that I wanna cover. So we're gonna do something like that. Okay, so real quick recording of the intro video and then a couple of geometry gems. If you have suggestions for something simple, again, something in the realm of like unitizing a vector, finding the plane based on 3 points, finding a circle based on 3 points, something like really, really simple and concise, let's do that, okay? Otherwise, yes, I think we're ready to start. So let's start. I'm going to switch to this background here. And then I'm going to pull up my script, which I have somewhere here. Where do I have this? I'm going to put it in front of me. All right, that's good. Okay, and I'm going to... Oh, I think I may have to bold. All right, so I'm going to do this, and then, all right. So I'm going to do that real quick. Can you hear me? Yes, I'm frozen. No, it's good. All right. For those of you, I see a lot of new people. I see a lot of new people in the chat right now. Hey, Arasto, how are you doing, sir? Good to see you. Konnichiwa. For those of you who are, oh, I hear you just got your second shot of the vaccine. Good stuff. Very good stuff. So for those of you, I see a lot of new people in the chat. So for those of you who are new, welcome to Parametric Camp. We do live streams on computational design. We record tutorials live. We hang out. We talk bad stuff about you know, fancy programming languages that shouldn't be there. You know, that kind of stuff. And yes, so you're gonna see what you're gonna see today is me re-recording a couple tutorials and then doing a couple geometry gems. Okay, so I'm going to start with the introduction to the parametric modeling video that is going to take me just a few minutes to record. Okay, so let's do this. Okay. Can you hear the background noise? The noise canceling in this thing is really good. I'm very happy with it. All right. Actually, no. Let me read this through because otherwise I'm not going to remember and then I'm going to start failing. Hold on. Just 1 minute. Created. Oh. All right. All right. Okay. So I got it. Let's do this. Hello, this is Jose Luis here at Parametric Camp, and I would like to welcome you to our new series, Introduction to Parametric Modeling. In this course, I would like to introduce you to the art of parametric modeling, which is the collection of techniques that we can use to generate three-dimensional form using rules and using algorithms. But why is this important? Well, if you have ever done or if you ever used conventional 3D modeling software, you might be used to modeling form by, for example, following a sequence of commands, like one after the other, where you specify the series of operations that you want to follow and their values that would lead you to going from having nothing to having a complex three-dimensional object, right? And an example of this can be, for example, you can create a circle with a particular radius, and then you can extrude it with a particular height, and then maybe you can create a bunch of boxes and subtract those boxes to create some kind of tower with windows, maybe, something like that, right? This process, which I may refer to in this playlist as static modeling, is great if you're just doing quick and dirty, if you just have to do one off, if that's okay. However, if at any point in the future you need to make changes to that shape, then the process actually becomes very difficult because your options are either undoing if you have the undo option and then redo your actions partially if you can, or make modifications on the object that has already been finished modeled, or simply just starting all over again, which of course is a lot of waste of time. So parametric modeling is a new paradigm in 3D modeling where what we do here is to explicitly design the rules and the sequences of operations, or in other words, the algorithm that lead to the creation of a particular three-dimensional form. And once that structure of relationships is there, then obtaining the final form is just as simple as choosing the values that we want for the parameters, parametric modeling of our algorithm. And like, for example, the radius or the height of the extrusion or how many boxes, etc. And then just pressing a button and obtaining the result. And this is great, not just because it lets us go back to our designs and modify our choices, etc. But most importantly, because once the algorithm that generates this particular family of forms has been created, then exploring all the possible solutions that it can give you is just as simple as changing a couple numbers and then pressing that button and regenerating the form again. And this process, that process of exploration, is a huge advantage in design processes, especially in the early stages, because at those stages you need to make decisions about the size, the shape, the appearance of certain objects, and having a quick way of iterating through a lot of versions is extremely efficient, and it's a really good help in making design decisions. And thinking design. That is why parametric modeling is one of the cornerstones of computational design, and it helps us be more creative. But don't worry too much, because I'll get deeper into what parametric modeling is farther down in more videos in this series. So in this series, what I'm going to do is I'm going to assume that you're a complete beginner, that you know absolutely nothing. I'm going to start from scratch, and I'm going to teach you everything that you need to know to start applying parametric modeling in your own creative processes. In terms of software, we're going to be using Grasshopper, which is a visual programming language for the 3D modeling platform called Rhinoceros. And however, the logics of what I'm going to be teaching you in this series can be ported to any other similar environment, like for example, Dynamo for Revit, like VVVV, like Fusion 360, Touch Designer. There's a lot of software packages that follow this paradigm. All right, that was good. I could have said Houdini, which I forgot, and I'm actually excited about, but it's fine. Don't worry. All right, so that was it. I'm very happy with that now. And now we can move on. How did that sound? As an intro to parametric modeling in general. Is there something you would have added, removed? Let me know. Oh, I could have said something in the... I'm going to repeat just the last part, and I'm going to cut and paste it. Yeah. In terms of software, we will be using Grasshopper, which is a visual programming language for the 3D modeling software called Rhinoceros from McNeil. However, the logics of what we're going to be learning in this series can be applied to many other similar environments, like for example, Dynamo for Revit, VVVV, Fusion 360, Touch Designer, Houdini. There's many modeling environments that follow this paradigm. And what you will learn in this playlist will be super, super useful if you're ever interested in you see what happens when I don't write it down? Oh my God. Let me just write it down so that I don't mess. All right. We have, let me see. All right. All right. So, yes, I think I know what I want to say now. So let me try again. All right. In terms of software, we're going to be using Grasshopper, which is a visual programming language for the 3D modeling software called Rhinoceros from McNeil. However, the logics of what we're going to be learning in this series apply to many other similar environments, such as, for example, Dynamo for Revit, VVVV, Fusion 360, Touch Designer, Houdini. There's many modeling environments that follow similar patterns and similar logics. And furthermore, if what you will learn in this playlist will be a fantastic introduction to what's called algorithmic thinking. And it will be super helpful if you are actually interested at some point in moving on to the next step, which is writing your own algorithms using computer programming languages like we do in other series or in other videos in this channel. All right, that's good. We're keeping it. We're keeping it. Woohoo! Keep it, keep it. Let me write myself a note here of what we just did and how we have to stitch together things, because otherwise I forget. Oh, I got it here. All right, so the recording, so final recording will be origin, new intro, add, replace the last software part and stitched the old project. What will you learn here? All right, we're good. Thank you for your patience. And we're back. Parametric modeling. All right, I'm going to take a 1-minute bio break and I'll be right back. And then we're going to do geometry gems. Do you have ideas for what geometry gems do you want to do? Probably vector algebra related stuff. Think about it and put it in the chat if you're interested. All righty. How's everyone doing? All right. What do we got going on? Okay. All right. So I have I have 3 candidates for. I have a few candidates for geometry gems to do today. I have unitizing a vector. That can be one. I have playing from 3 points. That can be another one. Angle between 2 vectors. That can be another one. And then a bunch of exercises which are grids of points and meshes from those grids. Oh, and I'm disconnected from the chat? Why is that? That sucks. Wait, hold on. Let me try it. Hello? Are you there? Hello? Hello? Did I disconnect? Um, can anyone tell me if I'm disconnected? Because I cannot really. What is going on here? Oh yeah, yeah. I was gone. Oh, that was bad. Can you hear me now? Yes. All right. Yes. Okay. Cool. Thank you. All right. So let's start with. If you don't have a strong opinion, let's start with unitizing a vector, and then we're gonna do a plane. We're gonna learn how to create a plane. That's actually quite interesting. We're gonna learn how to create a plane out of three vectors, 3 points. Sorry. Mm-hmm. And I'm gonna change the battery on my thing. Wait, give me a second. Let me grab some batteries. Okay. All right. I'm going to go. I'm going to go dark for a second. Hold on. All right. I'm back. Yes. Okay. Cool. So, geometry gems. I am kind of, let me review a couple of them just in case, because I have kind of forgotten like the rhythm that we used to write them. So, for example, change of basis. Hi, and welcome to this geometry gem where I'm going to expand on my previous geometry gem where we learned how to find the local coordinates of a point in a local coordinate system, not the world coordinate system. And now what we're going to do in this. Do I look older? What? Am I older? Uh, Wait, well, I also look, this is very low definition, but I look so much younger there, no? What's going on? Oh my God. Is to figure out how to now recreate. This was not even a year ago. It was like 6 months ago. From a reference system. Ah. Algorithm. But X of K of you can extract each one of the previous gen plus the prompt. And let's take a look. All right, so we did an intro, and then I had some drawings about what I wanted to explain. Yes, and then we just did it in C# scripting. Okay, so we can do that. All right, so then let's go to the whiteboard, and we're going to unitize a vector. So we need to draw a vector, and then we probably want to how can I explain that? So we have a vector, right? Like this, something like that. And that vector has three coordinates, which are going to be whatever, this one, and this one, right? So if we have, yeah, so if we have coordinate system like this, and like this, then it turns out that this vector has some kind of coordinates in this local system, correct? And those are going to be, the C coordinate, so that's going to be it's going to be, what is it going to be? It's going to be C, it's going to be C, and then this is going to be X, and this is going to be Y, right? Which is kind of weird to plot it that way. Am I liking this? So where do I want to go with this? So I want to say that it has particular coordinates, and then that the process is just as simple as figuring out the length of the vector. And once we have the length of the vector, creating a new vector where each one of the coordinates is divided by the length of the vector. Right? Do we have vector length geometry gems? Change of bases, distance between 2 points. We have distance between 2 points. I was inside of a square root. Maybe we should start with the vector length. Maybe we should start with vector length. Maybe that's not a bad idea. So let's start with calculating the length of a vector, and then we can move on to unitizing a vector. Yes. So I'm going to go back here. And then I'm going to remove this. And then I'm just going to say that this is y. It's going to be the y coordinate. This is going to be the x coordinate. And then this is going to be the c coordinate. All right. And I would like to say that I'm a little fussy. You see why we need to go back into the mood, because I'm rusty. You stop doing this for a month and you get rusty all of a sudden. So what is the best way to explain this? We have already a geometry gem where we have calculated the distance between 2 points. So should we use that as a way of explaining this? Am I saying that this is point 0, 0, 0, and that this is just point 0 and this is point whatever, so it boils down to the coordinates of the tip point? Oh my god, I'm a little fussy, and this is being kind of boring, right? Okay. Let me start over again. And then I'm going to do it with 2 dimensions. We have a vector, okay, and this vector has 2 coordinates. I have a vector, and the vector has coordinates, for example, x and y. And it turns out that those coordinates, if we place this vector at 0, 0, then those coordinates become x is here and y is here. And because Pythagorean theorem, with the Pythagorean theorem, we can see how, in order to find the length of this, so it turns out that the square length of this equals the addition of the square length of the 2 sides, which means that the length of this object is going to be the square root of the x coordinate of the vector squared plus the y coordinate of the vector squared. And turns out that in 3D, this also works exactly the same. Oh, am I drawing on top of myself? I am. It also works exactly the same, x squared plus y squared plus c squared. All right. And it and it also okay, so I'm actually going to remove this here. I'm going to delete this part here. And then I'm going to, where am I? Here. And then I turn this on, and I'm going to also remove this one here. And this one here. And I'm going to say that this is defined by x and y, and that is the same. This boils down to calculating the distance between 2 points that are on 0, 0 and xy, for which we already have a geometry gem. And then after that, it's just as simple as saying, oh, no, this, we don't need this anymore. And then calculating the length can be as simple as calculating the distance between those two. But for the sake of making it easier, we're just going to the Pythagorean theorem. And then here we're going to, I can draw that live while we're explaining that, which means that in 2D, if we want to find the length, we just have to calculate the length of one, and in 3D, it's just as simple as that. All right. So let me explain that, and then we can get going. All right. All right, this is going to be extremely easy because it only involves applying the Pythagorean theorem in a very straightforward way. And let's think about that. If we remember, vectors are starting over. I don't wanna start explaining what a vector is again. So let's start over. Okay, this is going to be super easy because it's going to involve just very straightforward application. Starting over. Okay, so this one is going to be super simple because it's going to involve simply applying the Pythagorean theorem in a very straightforward way. So let's take a look. If you remember, vectors are entities, geometrical entities that are defined by the coordinates of each one of its components in three-dimensional space. So if we take a look at this case in two-dimensional space, we can see that if we have a vector with x and y components, and if we want to do is we want to find the length of a vector, the linear length, then the problem is actually as simple as finding the distance between 2 points that are, one is going to be a point with the coordinates of the vector, and the other point is going to be 0, 0, because we can assume or we can imagine that the vector is just placed in the origin of coordinates. And we already have a geometry gem that deals with how to calculate the distance between 2 points. Is hopefully going to be popping up somewhere here on the screen. But we're just going to repeat this again for the sake of... So now you can see that what we have on the screen is a perfect square triangle. And then the Pythagorean theorem tells us that for square triangles, the square length of the longest side is equal to the sum of the squares of the smaller sides. So if we square the x coordinate of the vector plus the square of the y coordinate of the vector is going to be equal to the square of the length of that vector. And therefore, it follows very easily that the length of a vector is going to be the square root of that addition, the addition of the squares of both lengths of both coordinates of the vector. And this applies to 2D, but it also applies to 3D as well. So if you have a vector in three-dimensional coordinates, then the only thing you have to add is to the equation, you just have to add the z component. All right? It's just as simple as that. So let's see an example of how to implement this using, in our case, C# scripting with it Grasshopper. But anyway, this numerical relationship can be done in any platform or in any programming language that you can think of. So let's take a look at how to implement that with code. All right. Okay. So how do we implement that with code, right? That's a very good question. How are we doing? How's everyone doing? Oopsie. All right. So how are we doing? All right. So how am I going to prepare this? So I'm going to drop here 3 sliders. All right. I'm going to drop here 3 sliders, for example. And those are going to be the x and y and z coordinates. And I'm going to create a vector from 3 coordinates, right? And then I'm going to visualize. You're going to see that this vector is this vector here. And we're going to see also that the vector has this particular length here, which is already calculated by the component. Okay, so what we want to do now is and we're going to visualize it just for the sake of it. Visualization here, anchor, and then x, a point in 0, 0. All right, we can see the vector there. All righty. And then what we will want is to write a C# component that takes the vector and returns the length. And so how are we going to do that? Should I do that in the video? I can do that while we are doing the video, probably. Yes. So let's do that during the video. All right. I'm going to save this somewhere. Geometry Gem 13 vector length. Okay. Let's do this. Oh, and the bifocals thing. I actually installed something the other day? I've been getting a lot of suggestions from people from the community to use these other maybe I don't have it installed. I was trying it somewhere. Well, I'm just going to use bifocals for the time being, but somebody gave me a suggestion for a really nice plugin to do the visualization part. Okay. Parachute. I think it was, yeah, I think it was a different one, but I think the one that I ended up liking was Parachute, because you had the option here, you turn it on and it works always, and you don't have to have a plugin installed. I think that was the one. Should I can look that up later. Okay. So I'm going to start now by explaining that we have the vector, we drop a component, we calculate the length of the vector, or we take each one of the components, and then we calculate the square root, and then we return that. And that's just as simple as that. Yeah, you're right, Victor. That's multilingual, right? How awesome is multilingual? For all of you who don't know, multilingual is a component translation utility that Victor Lin has been working on for quite some time already. It's very, very nice. I contributed a little bit to that, to the Spanish translation, didn't I? Sunglasses is the one that I was suggested, but I did like Parachute better, I think. Anyway, let's... Hi, and welcome to another geometry. What? Where in this one, what we're going to do is we're going to... Stop. Okay. Right, so let's start. Okay, so we are here back in Grasshopper, and what I have done is I have created a definition where I can create a custom vector with custom X, Y, and Z coordinates, and you can see that I am also using a display component to visualize this vector in 3 dimensions. And because remember, vectors don't really have a location, they only have direction and magnitude, I have forced the display of this vector to start at the coordinates 0, 0, 0. That's why this vector is anchored on the origin of coordinates. Now, what's interesting is that the component in Grasshopper that creates vectors already gives me the length of this vector automatically. So this is going to be great for us to check if the computation that we're going to do is going to be valid. And then what we're going to do is we're going to create a C# script component that we're going to use to mimic this, to mimic the inputs of, to basically mimic this component here. So what I'm going to do is I'm going to remove one of the inputs. I'm going to right click here and type V, and then I'm going to right click here and make sure that the input is of the type vector 3D, so that is correctly casted. And then here the output, I'm going to right click and rename this output to length. So that now if I plug this in here and if I input the vector, then this component should perform the calculations to give me the length of that vector, which right now it's not doing because I just struck this. So now I'm going to double click here and I'm going to open my C# scripting window where I'm going to implement that logic. All right. And then the logic is going to be super simple. The first thing that I'm going to do is I'm going to write this very explicitly. I'm going to retrieve the vector coordinates, and now I'm going to do it by saying I'm going to create a variable of the type double, which is a number with a lot of precision, which is going to be called x, and that's going to be v dot, and then you see all the properties that show up. This is going to be the x coordinate of that vector. All right. Then I can say double y is v dot y, and double z is v dot capital C. So now I have three variables that contain the values for the x, y, z coordinates. Now what I need to do is I need to now compute the length, which I'm going to do by saying I'm going to create a new variable called length, and this is going to be math dot square root. I'm going to compute the square root of x squared plus y squared plus z squared. Now, how do I square a number? Well, we could use the math.power function, and we could say I want to elevate the value of x to the number 2. All right. However, squaring numbers is a really simple operation, and it's done much faster. Instead of calling an additional function, it's much faster done by just saying, like, I'm just going to multiply the number by itself. So I'm going to do x plus s times x plus y times y plus z times z. Correct? And then once we have that length, then what I can do is I can output that value from the L object. So that's going to be L equal, the output of the component is going to be equal to that value that I just calculated here. And if I press play, you can see that, ta-da, the values actually match. And if I change the corresponding any of the coordinates, those values actually match. All right. So that's it. It was just as simple as that. Now, because you know me a little bit now, I'm going to change the code a little bit to make it a bit more functional and nicer and reusable. So for example, I'm actually going to create a function that I can copy paste between my different pieces of code and that I can reuse. So that function, I'm going to call it, for example, vector length. All right. And then that function is going to take as an input, is going to take an object of the type vector 3D in this case, because we are in Grasshopper using Rhino Common. If you're doing Unity, or if you're doing some other software, then the type of element will be slightly different. Okay. Now I'm going to name this lowercase v, for example. I'm going to open and close curly brackets. And I need to remember that this function takes one vector and then returns a number with the length. So the return value has to be of the type double. And now inside of this function, I could basically just copy paste all of this and then say the return value is going to be length, and that's it. And then here for the outputs, what I could do is I could say the output of L is going to be the result of calculating the vector length of V. All right. However, quick thing, this needs to be lowercase because I renamed this argument as lowercase. So now this should work, no problem. All right. So that's great. And in case I like writing very verbose, very explicit code when I'm doing these tutorials, but in case you want a little more of like elegant lean code, I'm not sure that's a good practice, but anyway, you could say, well, instead of retrieving this, why don't I just use them here right away? So what you could do is you can just say, I'm going to directly read from the vector. I'm going to say v.x times v dot capital X plus v dot y times v dot y plus v dot c times v dot capital C. Okay? And then you return that. Or even more shorthand for this, you could just take this and paste it here right away, and then the function returns directly the square root of the values of the value computed from the coordinates of that vector. And then you click run, and then this executes, and it's a little faster actually. All right. Alrighty. So I think that's all I had for today. And as you can see, this operation doesn't really need anything. This operation is just taking the coordinates and doing some arithmetic, some Pythagorean theorem with these values. If you wanted instead to use the functionality that is coming in this case with Rhino and Grasshopper, then it turns out that the vector 3D component already has something that computes the length for you. So you don't have to write that on your own. So this, for example, we could rename this. And then we could say, instead of that, I'm just going to use Rhino Commons capacities and say vector have to have some kind of length property. So you can see here, there is a length property that basically computes the length of this vector internally and returns that value. So I'm going that, if I do that, that is also going to work. But in this case, now we rely on Rhino Common to do that operation. In this case, we have manually done that operation ourselves. Okay, so whichever way you find better. I like doing things myself very often, but I also don't like to reinvent the wheel every time. So it's up to you. Okay, but knowing where this comes from is very useful. Yeah, I think in my opinion. All right. Thank you very much. This was how to calculate the length of a vector. If you like this video, you may want to hit the like button or maybe consider subscribing to the channel and all those things that we do in modern YouTube days. Thanks a lot and see you on the next Geometry Jam maybe. Bye. All right. All right. And it's gonna be Rhino Commons way. All right. Okay. Yes, you have revised the sign of it. Now it's version 2 and final. Yeah, well, good luck with final. Final is never final. Final is final, final version 2, final, definite final. We've all been there. All right, let me do the intro to the video. Hi, this is Jose Luis here at Parametric Camp, and let me welcome you to a new Geometry Jam where we're going to learn how to calculate the length of a vector in three-dimensional space. So you're going to see that here I have a vector in 3D that I can control with X and Y and Z coordinates. And then you can see that Grasshoppers automatically gives me the length, but I have written, and I will explain how this works, I have written what the algorithm to generate the length of a vector looks like, which is very simply based on the Pythagorean theorem. So I'm just gonna, why don't we just get hands-on? I'm going to explain first conceptually where this is coming from, and then I'm going to explain how to implement that right in computer code. Let's take a look at that. All right, so that was computing the length of a vector. And the next thing that we want to do was, what was the other geometry gem? Unitizing a vector, all right? Okay, so I may want to use this one. Okay. Let me save this and let me write myself a note here. Let me write myself a note here. That all right. What else? Yes. We were going to do how to unitize a vector. I think I might just use this diagram, a similar diagram to this one. Okay, so let me just save this diagram here. And then let me make another one. Save. Wait. Save as. Okay. All right. So that. Okay. Here. Oops. Oopsies. All right. Where is the drawing thingy? How's everyone holding on? Is it hot, wherever you are? Because it's very hot here in Cambridge today. It's the weather has been super nice, and now today it's not great. So we have this, and what I want to say is that I have this, and then this vector has whatever length. All right, and then what we want to do is we want to be able to find a new vector. Sorry, I'm actually going to the length of this vector, which can be whatever. And then what I want to do is I want to create a new vector, something like this, where I know that the length is going to be equal to 1 unit. Except during the winter, which is what, 75, 70, which is still super warm for Boston standards. Actually, let me undo this. Okay. I'm going to draw all this stuff here above. The length of this vector is going to be whatever. And then what I want to do is I want to create a new vector. And then this vector has to have a length of 1 unit. It can get to the 60s. Come on, cry me a river, Hector. That is springtime here in Boston. Anyway, so what are we going to do with that? So what that boils down is that we have X and Y. And then when we do that, then how do you represent an unit vector? I forget what the notation was. I may want to use that notation. Okay, so let me just delete. Have I told you how I'm really tired of this sketching program that I use? How I keep complaining and then I never actually. So I'm going to say that this vector is a vector. It's called vector v. All right. And we're going to say that the length of vector v has to be is whatever, can be whatever. Now what I want is to create a new vector, and that vector is going to be called v, lowercase v, and I'm going to give it a hat. And what I want to say with that is that the length of v hat is going to be equal to the length of v hat, or bad, has to be equal to the value of 1. And then, oh no, okay. Okay, so here I'm going to delete this. And then here I'm going to, nope, not this one, not this one. V with a hat. And then, okay. And then here I'm going to delete this. Because it turns out that this is going to be Vx, and oh no, that's Vy. That's Vy, and this is going to be Vx. And it turns out that here we can have v hat x. Ah, y. It's y. And v hat x. All right. And all right. And then I want to explain that you can see how there's a rule of proportionality. And if the unit is 3, you So it turns out that in order to calculate v, hat, turns out, oops, no, I need a new, yes, in order to do v hat is going to be equal to the v vector divided by the length of the v vector. Ooh, oops, that's a lot. Or, and what this means also is that r, so v hat x is going to be equal to v x divided by the length of v x, then v hat y is going to be equal to vy divided by the length of v, and then v hat z is going to be equal to the z coordinate of the x vector divided by, all right. And perhaps we can make, there you go, here. Okay. I think this starts looking better. I have to remember in the intro to explain that unitizing vector is a really, really common operation to do, because working with unit vectors is a very nice thing. I need to remember to do that. Okay. Wonderful. So let's break down the rules for unitizing a vector. So let's say we have any vector in three-dimensional space, and that we're going to name that vector v with an arrow. This is a very common way of notating vectors. And then what we're going to do is we're also going to assume that the length of that vector is whatever value. We don't really know, we can find it, it's very easy to compute, but it's whatever value it is. It's probably not the value of 1. And I'm going to denote the length of a vector by using these double vertical bars around the vector name. All right, so this expression that you see here means that the length of vector v is whatever. Okay, And then what we want to do is from vector v, we want to find a new vector that we're going to call v hat. And the hat is a very common notation for unit vectors. And we're going to find a new vector v hat, that has a property, which is that it has the same orientation and the same direction of the original v vector, but the length is going to be 1 unit in whichever system we're measuring. It doesn't really matter. So we're going to assume we want to find what the coordinates of vector v hat are, so that the length of that vector satisfies that it's equal to 1. Or in other words, we want to turn vector v into a vector with the same direction and the same magnitude, but just in the same direction, but with only the length of 1. How can we do that? Well, if you think about this, you remember that vectors have x and y and z coordinates, whatever those are. I'm doing this diagram in 2D, but everything that I'm explaining will work in 3D the same. And that what we want is to find the coordinates of a new vector in the same direction, but only with a unit length. And if you think about this, turns out that you can see from this diagram that there is a very clear rule of proportionality between the original vector and the unitized vector. So think about this. If the original vector has a magnitude of 2 units, then if you want to find a vector of unit 1, then basically what you have to do is divide each one of the coordinates by 2, right? Or if you have a vector of 5 units long, then what you need to do in order to find the unit vector is divide each one of the coordinates by 5, right? You just need to shrink down those coordinates by a factor of the length. So what that means technically is that in order to find a unit vector v hat from any other vector, what we need to do is we need to take the original vector and we need to divide that vector by the length of such a vector. So whatever the length of this vector is, we need to divide it by its own length to find the vector with the same direction, but just 1 unit length. And what does dividing a vector by a number, what does that mean? Well, what it means practically is to take each one of the coordinates of the vector, and then, which are numbers, and divide that coordinate by the length of the vector, and then use those coordinates to assemble the new unit vector. I don't know if I overcomplicated the way I explained this or if the way I notated this on the screen, but long story short, in order to find a unit vector from an original one, the only thing you need to do is take the original vector and divide each one of its coordinates by the length of that vector. And those new coordinates will be the coordinates of a unit vector that has the same direction, the same orientation, but the magnitude is going to be 1. And this is what I've tried to express with maybe a little bit of more mathematical notation that I typically do in this channel. But I think simple mathematical notation is healthy sometimes to be exposed to. Anyway, now let's take a look at how can we do that using writing computer code, okay? All right. All right, so we're here now, and we're going to save this file as okay, vector unit. And what I'm going to do is I'm going to disconnect this. Okay, so I have this vector that I'm displaying here, and then I'm going to unitize unit vector. Then I'm going to make that vector unit, okay, and I'm going to copy this here so we can see the results. Okay, and I'm also going to just copy paste this in here. Oops, oopsies. So that we can, yes, so we can see the unit vector here. And then we're just going to write here a component that is going to mimic this one here, which is taking the vector and returning a new vector, which is the unit vector. Okay, so I can explain that now. Wonderful. So in this case, I'm going to be using Grasshopper for Rhinoceros, which is a visual programming language which already has a geometry kernel. So we already have vector elements, etc., etc. But if you're using a different environment like Unity or whatever, you have very similar capacities here. So what I'm going to do now, what I have here is a Grasshopper definition where I can create a vector from scratch, all right? And then with X, Y, and Z coordinates. And you can see that I'm creating a vector and I'm displaying it anchored at coordinates 0, 0, 0. And then I have taken that vector and I have fed it to another component that takes any vector and unitizes that vector. And you can see that I have here this second vector, which has the same direction, the same orientation, but is 1 unit long. And you can see how the coordinates of this vector are different from the original. And even if I crank it very small, each one of the coordinates, you can see how the vector still actually, and now the vector, the unit vector is actually longer than the original one. Anyway, so what we're going to do is we're going to try to mimic the behavior of this component by writing a C# script component that is going to take one vector. I'm going to call this vector in, all right? And I'm going to make sure that this, I'm going to right click, type hint, vector 3D. I'm going to make sure that this is of the type vector. And then the output is going to be v out, which is, or v, well, I can do v unit, for example, and this is going to be v, simple v. And then I'm going to plug this in here. I'm going to copy and paste this. And then what I would like to do, oops, sorry, no, I'm going to plug in here. I'm going to take the original vector and I'm going to write here some code that is going to return a new vector with unitized coordinates. So how are we going to do that? It's going to be super easy. The first thing that I'm going to do is I'm going to compute the length of the original vector, all right? And how can I do that? Well, I'm going to create a vector variable that is going to be called length, and I could do it two ways. So I could do, for example, because I am working in Grasshopper and Rhino, I know that vectors, for example, v, which is the input, we know that vectors have a property that is called length that I can use to recalculate and read that vector length right away. However, in my previous geometry gem, where we calculated the length of vectors, I wrote this function called vector length that takes one input vector and returns its length, which I kind of like, so I'm going to reuse that. So I just copied that, I pasted that function here, okay? And then what I'm going to do is I'm going to use that function, so vector length, and then I'm going to pass vector v, and that is going to give me the length of that vector, all right? And then what I'm going to do now is I'm going to calculate each one of the coordinates of the new unitized compute unitize unit vector coordinates. So what I'm going to do is double ux, I'm going to call it vx, and that's going to be whatever the coordinate of the x was divided by that length that I just calculated. Then I'm going to say vy is going to be the original y coordinate of the original vector divided by the length of that vector. And then vz is going to be the coordinate z of the original vector divided by that length. So now I have those three coordinates, but remember that what I want to return is actually a vector object. So now create a vector object in Rhino Common, which is what the geometry kernel for Grasshopper is. We have a class called vector3d that we can use to create vectors. So what I'm going to do is I'm going to create a new variable called unit vector, which is going to be a new vector. I'm going to construct a new vector 3D object. And then the coordinates are going to be those coordinates that I just calculated, Vx, Vy, and Vz. And then I'm going to output that through the component, which is called VUnit, was the output, is going to be unit vector. That new vector that I just created over here. So let's see if this works. So I'm going to generate that, okay? And then I'm going to compare these two, and it looks like they are pretty identical. So that's great. I'm going to, so that's pretty good. And just to double check, this is the vector length script that I did in my previous geometry jam when we were calculating lengths of vectors. So I'm going to plug that in here, and you can see that it tells me that this unit vector has a length of 1. So that's great. So it looks like things work. And then if I modify any of the input components, you can see that the vector changes, but the length is still always being 1. Can you see that on the screen? Yes, you can see that on the screen. Okay, so that was unitizing a vector. Super simple. Remember, the way to unitize a vector is to create a new vector which has coordinates equal to the original ones divided by the length of the original vector. As simple as that. Okay? Thank you very much. And if you like what you saw, you found it helpful, entertaining, or whatever, maybe consider liking this video, subscribing to the channel, turning on notifications to see when we go live, etc., etc. And thanks a lot, and see you on other videos. Bye bye. Okay, and now the intro video. Woo. And that's going to be it for today, I think. So intro video is going to be, what is it going to be? The intro video is going to be, oh, I didn't quite make a function out of this. Oh, and I didn't really explain how to do that in, all right. I didn't explain how to do that in the Rhino way. Yeah, that's not great. I think I want to do that. Okay, so we're going to record a chunk where I explain how to do this the Rhino way as well. Now, we have learned how to do this the manual way, and you know me already. This is probably something that we want to perhaps abstract into a function. So I would want to do something like, for example, creating here a function that returns a vector 3D given a unit vector. So for example, given a vector 3D object lowercase v is going to return another vector 3D, which is the same vector, but in a unit way. Okay, and then I can just copy paste most of this, except for this that I have to rename to lowercase v. All right, so here I can calculate the length using this function that has to be available, okay? And then I could do here, what I could do is I could say, can I calculate the unit vector of uppercase V? And that should give me the same result, except that the name V does not exist in line 72. Yes, I forgot to replace this one here. So I'm going to replace that one there, and then it's still not working. Not all. Oh yeah, because I forgot to return the vector actually. So return unit vector. All right, and now it works, and it's a unit vector, and this is the same numbers. So that's great. So now we have this in a form, which is a function that we can reuse and share between different parts of our code. Now, this is the manual way of unitizing a vector, but for those of you who are Rhino and Grasshopper users, you may want to learn the way to do this with Rhino common, which is, for example, this is going to be the manual way. And here, I'm going to say the Rhino common way. And the Rhino common way is doing the following. So the Rhino common way is we can take the vector v, and then we can unitize it, and there is a function that lives inside of vectors. And then what this is going to do is that it's going to take vector v and it's going to unitize it in place. In place means that it's not going to return a new vector that is now a unit, the way we have done it in our function, but it's going to take the vector v and it's going to modify that vector. Okay, so we're going to lose, in a way, the original vector for this new unit one. So it's a slightly different behavior, and the pros and cons is that maybe it's faster and a bit more memory efficient, but we also lose, if we will, the original data. So if we ever need to go back to the original coordinates for whatever reason, we can't do that because we have actively changed this vector. So that's one way to see it. The other way to see it is that if you look at the Rhino common way, when I open unitize, you can see that this function actually returns a Boolean, and instead of returning a new value. Why is that? It returns a Boolean because not all vectors can actually be unitized. Let me show you an example of that. So for example, I'm going to create a variable called success, and it's going to be equal to the result of whatever happened here. If success was false, then I'm going to display a message here. This component add runtime message, grasshopper runtime message level error, and that's going to be cannot unitize vector. All right. So let me show you this. Okay. So for example, let's say that I'm going to run this code, and right now it's well, I haven't. So v unit is going to be equal to this new vector v that I just unitized, right? And you can see that right now it's working and it's giving me the same result. But if I now take all the coordinates of this vector and I zero each one of them, all of them together, then guess what's going to happen? I get here an error that says cannot unitize this vector. And why is that? Well, if you think about it, a vector that is a 0, 0 vector that has no length or no direction whatsoever cannot be unitized because the result has infinite solutions, if you will, because the vector could be pointing anywhere, because it's not pointing anywhere really. It doesn't have a direction. That is the geometric interpretation. If you want the mathematical interpretation, if you look at the algorithm for unitizing a vector involves dividing each one of the coordinates by a number, the length of the vector. It turns out that if this length happens to be 0, then we know that dividing a number by 0 is an indeterminacy. It's a calculation that cannot be done, that returns infinity or other kinds of. So that cannot be computed, and therefore there's no solution to that operation. That is why the Rhino common function doesn't really return a vector. What it returns is a Boolean flag telling us if we did successfully unitize that vector or not, if it was possible. Okay? All right. Cool. So that was vector unification, unitization, or I don't even know how to call that. Both the manual way and the Rhino grasshopper way. Remember, unitizing a vector is just as simple as taking each one of its coordinates and dividing them by the length of the vector and creating a new vector with those divided coordinates. Just as simple as that. All right? Beautiful. With that, I think that's what I wanted to get to today. Thank you very much. If you found this video useful or entertaining or you learned something, maybe you want to consider liking the video, subscribing to the channel, maybe turning on notifications to see when we go live, when we publish new videos, etc., etc. And in the meantime, I'll see you in any other of the videos in this channel. Thanks a lot. Bye bye. All right, so let me record the introduction and we are probably good to go. All right. Hi, this is Jose Luis here at Parametric Camp, and let me welcome you to another geometry gem where we're going to learn how to unitize vectors. And unitizing vectors is the process of taking a vector that has whatever direction and orientation in three-dimensional space and creating a new one that has the same direction and the same orientation, but whose magnitude is going to be the unit, or in whichever units you're measuring that. We're going to be implementing this in Grasshopper for Rhino using the C# scripting language, and we're going to do it both the manual way, so I'm going to teach you how to do this from scratch so that you can apply this in any other environment, or if you're more Rhino inclined, I'm going to teach you how to use the Rhino common to perform that operation automatically. Okay? So, but first, before we do any of this, as usual, let's take a look conceptually at what unitizing a vector is and how the algorithm works. Choo-choo! All right, I think we're done for today. I think this is what I wanted to get to. I would do another one, but it's going to take me a while, and I have a meeting at 1 p.m. So I think we're good. I'm very happy to be here. I have a few minutes if you have any questions, if you want to do social, etc., etc. Otherwise, friendly reminder, we are back on track and we're going to keep going live stream for the month of August and until Christmas. Why not? And also friendly reminder that I'm feeling very strongly towards doing another small hackathon, marathon, coding-thon, whatever you want to call that, to record a set of videos for this new playlist that I want to do, which is going to be C# development in Grasshopper. Okay, so stay tuned for the announcements of that. I need to decide when are we doing that, how are we doing that, but we've already decided in the chat that we want at least the first session to be all of us writing a curriculum together of what the videos are going to be and what content should be in them, which should be really cool. Hey, Kieran, good to see you too again. So if you want to know and be up to date about when this is going to happen, remember to join our Discord server, or remember to join the Google Calendar. I'm posting all the links on the chat right now. Remember to join the Google Calendar so that you can get a notification when we go live next time. Okay, which I think will probably be sometime next week. We're going to start doing this. All right, I have to wrap up a couple of things, but I would like to get that done very soon. Awesome. Thanks as usual. Thank you very much, everyone, for being there. I love being in the company of human beings when I do this. Hey, Andres, I was doing full decaf today. I'm back on decaf track. I have not had a single sip of caffeine today. I'm super proud. Except, I think the last caffeine I had was when I met Hector, that I had two full coffees, and I went back home and I was like, I was coding until 3 a.m. that day. I'm gonna blame this on Hector for giving me real coffee, very strong real coffee. He had a very nice coffee shop, by the way. Anyway, thanks everyone. I was very happy to be here, and I'll see you on the next live stream sometime next week. Okay? Have a good weekend. Enjoy the rest of the summer. Go outside, hike a mountain, swim on the sea, whatever nature you can throw up, whatever nature you can throw to yourself. Okay? Have a good one. Bye bye.